What's up and welcome back, guys. Today we're going to be talking about understanding residual plots for the Regents exam. This is a really quick and easy lesson. All right, we're just going to show you how residual plots look on the Regents and what it is they want from you. Now basically, residual plots help you determine if the line of best fit is a good fit or not a good fit for the data you are analyzing. Now we talked about lines of best fit in the previous lesson with correlation coefficients, and I'll put a card up at the top for that. But all the Regents is going to do with residual plots, and all they're going to make you do is they're just going to make you tell us, is it a good fit or is it not a good fit with the graph they give you? And then why is it a good fit or not a good fit? That is it. No work needs to be done. So let's look at two examples here. So in graph A, we say graph A is a good fit, or sometimes the Regents will use best linear fit. They both mean the same thing. We say graph A is a good fit because the data plots form no pattern, right? If you notice, there is absolutely no pattern here as these plots go along in the graph. And they are evenly close to the x-axis, which is also true. Now, keep in mind, this graph is 0.6. That means this is actually less than 1. So these are they're like right on top of the x-axis, and they're like right below the x-axis. So they're all very close to the x-axis. All right, and they're evenly dispersed throughout. There is no pattern, so we say that is a good fit. If you were to look at graph B, notice it is different. Notice the data plots do form a pattern, and that is true. As you go along the x-axis, the plots are going up, they go up, they go up, they hit this point around here, and then they start to come back down, forming a pattern. And then we also say that the plots are not all close to the x-axis, which is also true. A few of these plots right here are close, but then when you get to here, these plots are far away. And then they get close again over here. All right, so that's what not a good fit looks like. It forms a pattern, and not all the plots are close to the x-axis, which is evident here in this graph B. So that is basically all you need to know with residual plots. You have to be able to tell us, does it look like this where there's no pattern and they are close to the x-axis? That's a good fit. Is there a pattern and some are far away from the x-axis? They're not all close to the x-axis. That is not a good fit. That's all you have to tell us. Let's take a look now at a Regents question. Okay guys, let's take a look at a Part 1 Regents question. Now this is a Part 1 Regents question because it is multiple choice and it's very straightforward, and the Regents can't really ask you this in many different ways. So once you understand these and see them, it'll be easy for you. Now, after performing analysis on a set of data, Johanna examined the scatter plots of the residual values for each analysis. Which scatter plot indicates the best linear fit for the data? Now remember, best linear fit means good fit. And what does good fit mean? It means we are looking for the graph that has no pattern. Please do not mind my sloppy handwriting here. That's what we're looking for, guys. We're looking for the graph that gives us no pattern, okay? So let's take a look at each choice here. Which choice is no pattern and is all the data is pretty much close to your x-axis? Well, guys, that's very simple. That to me is choice 3, okay? Choice 3 is your good fit, okay? Because all of this data is close to your x-axis, all right? And there is no pattern here. Notice choice 1. Some are high above the x-axis, some are low, some are high again, and it also does form a pattern. If you look carefully, it almost looks like a positive quadratic function. So we say not a good fit. So that's not our answer. This also, some are close, some are far, some are far, does form a pattern, almost looks like an absolute value function to me. That forms a pattern. That is also not a good fit. And then, of course, choice 4, far away from the x, close to the x, far away from the x, far away from the x. It does form a pattern. If you were to kind of draw a line through this, it would make a negative quadratic function. Also not a good fit because it forms a pattern. So the only choice that does not have a pattern is choice 3. That's how it will come up on a Part 1 Regents. Now, let's take a look at a Part 2 Regents question. Okay, here's a Part 2 Regents question, guys, all right? Now, notice in a Part 2 Regents question, not multiple choice, all right? So it says, the residual plots from 2 different sets of bivariate data are graphed below. Now, don't get crazy about bivariate data, guys. That just means it's comparing 2 different pieces of data, which you have here for the y-axis and then the x-axis. Now, here's what it says. It says, explain, using evidence from graph A and graph B, which graph indicates that the model for the data is a good fit. So remember, that's just us memorizing what a good fit is. Remember what we said about a good fit. A good fit is no pattern and close to the x-axis. Well, which of these graphs is no pattern and close to the x-axis? Well, graph A. So here's what you're going to write for graph A to show that. You're going to say, and I already have it typed out because my handwriting is terrible. Guys, graph A is a good fit because the data does not form a pattern. And that is true. Okay, there is no pattern here. That's why it's a good fit. Now, that means graph B is not a good fit. Remember, it says using evidence from graph A and graph B. That means you have to mention graph B in your answer. So what do you say about graph B? You would say graph B is not a good fit because it does form a pattern. All right, that's how you would answer a Part 2 on the Regents. The reason why I had these pre-typed is because my handwriting, guys, with this pad is absolutely terrible. You will hate it. So at least now it's nice and neat, and you can copy that and read that and see that. All right, so graph A is a good fit because there is no pattern. Graph B is not a good fit because it does form a pattern. 2 points in the Regents. That's all you need to get full credit on that question. Now, let's take a look at a Part 3 worth 4 points on a Regents. All right, guys, let's take a look at Part 3 Regents question worth 4 points. It says the table below represents the residuals for a line of best fit. So here is your table here. You have your x values, and of course, residual, guys, is the y values, right? Which it's labeled for you here. Here's your y-axis. The first thing the Regents want you to do is plot these residuals on the set of axes below. So instead of giving you the residual plot, they're going to make you plot it, which is actually good for you because that's very easy to do, and that's going to give you points. So we plot these like we plot all points. There's nothing different here. We have done this before. So the first set is +2 and then +2 on the residual. So you go down here to 0. +2 for x is over 2 and up 2. Boom, there's your first point. Then we have +3 and +1. Go back to 0. +3 for x is to the right 3. +1 for y or the residual is up 1. Boom. Then it's +3, -1. You go back to 0. +3 for x puts you at 3. But now -1 means you go down 1. Simple enough. +4, -2. That means you go to the right 4 and you go down 2. Perfect. +6, -3. You go to the right 6. You go down 3. +7, -2, you go to the right 7 and you go down 2. +8, -1, you go to the right 8, you go down 1. +9, +2, you go to the right 9, but now since it's a +2, you go up 2. Then it's +9 again and 0, that means you go to the right 9. 0 means you're going to put a point right on the x-axis. And then, of course, the last one, +10, +3, you go to the right 10, and then you go up 3. There is your residual plot right there. You're getting points on your Regents just for that. Now, we're not going to stop there, of course. We have more work to do, but it's very simple. So now, what we want is Using the plot, assess the fit of the line for the residuals and justify your answer. So guys, they basically just want you to say, now that you plotted this, what kind of residual plot is it? Is it a good fit or is it not a good fit? Well, what did we learn about good fits and not a good fits? I see a pattern here, right? If I were to draw a line through this, it would look like a quadratic function. Also, far away from x, far away from x, far away from x. Not all these plots are close to the x-axis. Therefore, we know this is the plot above is not a good fit because the data form a pattern. So that's what you would write on the regions. The plot above is not a good fit because the data forms a pattern. And that's exactly what you have up here, okay? So guys, that is basically it for residual plots. Good fit, not a good fit. Remember, a good fit does not form a pattern. Not a good fit does form a pattern. It's just that simple. Any questions, guys? Email me at bwritingcihs@yahoo.com. Comment below on what you liked, what you didn't like, or what you'd like to see. Please subscribe, like, and share this video. And as always, guys, please, you and your family stay safe, and I will see you on the next video lesson.